Good morning all. This is Dr. D. Kalandar Basha, working as Associate Professor in the Department of ECE, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss the pin description of 8051 microcontroller. The slides are prepared by referring the textbook The 8051 Microcontroller, authors Kenneth J. Ayala, publication Cengage Learning. 8051 microcontroller is an 8-bit microcontroller that contains 40 pins of dual-in package. Out of the 40 pins, 32 pins are allotted to I/O ports, as 8051 is consist of 4 ports, port 0, port 1, port 2, port 3, each of size 8. So 8 into 4, 32 bits are reserved for I/O operations. However, in 8051 microcontroller, there exist multiple pins which are assigned more than one signal. The logic state of the pin decides whether the pin is operating in input or output mode. Thus, the logic 1 at the I/O port configure the pin as an input port, while the logic 0 at the I/O port pin shows the enabling of the output. The figure 1 shows the pin diagram of 8051 microcontroller, which is 40 pin IC dual-in package. Port pin 1 to pin 8, these are corresponding to port 1 0 bit, port 1 1 bit till port 1 7th bit. Next bit is RST, which is for resetting the microcontroller. Next, port 3, port 3.0 to port 3.7, these are port 3 pins. These are having multiple functionality. They will act as port as well as few functionality are defined on these lines. RxD, receive data, TXD, transmit data, INT 0 bar, which is external interrupt 0, INT 1 bar, which is external interrupt 1, timer 0, timer 1 interrupts on T0, T1, write bar, read bar. Next, XTAL1, XTAL2, which we are going to be apply the clock pulses for system operation. Ground. Next, port 2.02, port 2.7, these 8 bits are corresponding to port 2. This will serve as address lines for A8 to A15. The next pin is for PSEN bar, program store enable. ALE, address latch enable for programming. EA bar or VPP, that is external access or VPP. Port 002, port 07, which is 8 bits of port 0. This will serve as address and data lines from AD0 to AD7. The 40th pin is the power supply VCC. We will see the pin description. First pin we are discussing is VCC, which is having pin number is 40. 8051 microcontroller operates on a 5 volts supply voltage. So VCC is connected to 5 volts. Thus, this pin solely assigned to VCC at which the supply voltage is provided. So, this will provide the biasing voltage necessary for the internal elements of the microcontroller. Ground, that is pin number 20. This pin is allotted to ground that passes the excess current of the microcontroller to the ground. Next pins are from pin number 32 to 39. These are corresponding to port 0. So, port 0 is consist of total 8 pins. So, these 8 pins act as bidirectional input-output ports as well as multiplexed data and address lines. Here, the lower order address and data bus, that is from AD0 to AD7, are multiplexed together with the I/O ports. The port 0 do not hold any internal pull-ups. So, in order to use it as I/O port, external pull-ups are required. The pin, when gets enabled, shows the accessing of data from the desired address of external memory. Hence, port 0 is utilized as a multiplexed address or data. lies. The next pins are from pin number 1 to pin number 8, which are corresponding to port 1, which is a 8-bit port. These pins are assigned specifically to bidirectional I/O ports, including the internal pull-ups, and are used for any other functions in 8051 microcontroller IC. Port 2, that is pin numbers from 21 to 28. These pins are assigned bidirectional I/O port for port 2. Also, when external memory is needed to access, then these lines pin act as higher order address lines, that is from A8 to A15. The next one is port 3, which are on pin numbers 10 to 17. These pins are bidirectional input-output ports of port 3. Along with this, all these pins in port 3 act as multi-purpose pins. This means, despite serving as input-output port, these pins also hold some special functions which are listed in the below. So, port 3.0 is also used for RxD, which is receive data. Whenever the processor wants to perform the serial communication for receiving, the data will be received on the RxD line. Port 3.1, which is for TXD, whenever the processor wants to transmit the data serially, the data will be transmitted on the line TXD. P3.2, which is INT0 bar, which is to accept the external interrupts on INT0 signal. Next, P3.3. So this is also external interrupt. So two external interrupts are supported in 8051 microcontroller. One is INT0 and the one is INT1. Port 3.4, which is for timer interrupt for timer 0. Port 3.5, which is an interrupt for timer 1, T1. P3.6, which is the active low read signal. Whenever the processor wants to write some data to the I/O device or memory, the status will be indicated on the P3.6 is equivalent to 0. P3.7, which is a read signal, which is a active low signal. So whenever the processor wants to read the data reading either from the memory or I/O device will be signified on this line. So P3.0 RxD, this pin is used for serial port to receive the data in UART mode, while in shift register mode, it acts as data I/O pin. P3.1 TXD, which is pin number 11. This is another pin for serial port that is used to transmit data in UART mode. However, in shift register mode, it acts as clock output. Pin 3.2 INT0 bar. This is an interrupt 0 input which shows the presence of an interrupt when an active low signal is generated at this pin. P3.3, which is INT1 bar, which is external interrupt on pin number 13. It is an interrupt 1 input pin which, when goes active low, shows the existence of the interrupt in the system. The next P3.4 T0 on the pin number 14, this pin is assigned to timer 0 of the microcontroller, and active high at this pin indicates the system producing a time delay using the timer 0. P3.5, which is for timer 1, pin configuration, pin number is 15. This pin is allotted to timer 1, the same purpose which we are having for T0. Only difference is P3.0 is for timer 0, whereas P3.5 it is for timer 1. P3.6, which is a write bar on the pin number 16. This pin get active, that means it is active low signal whenever a write operation is performed. An active low signal at this pin indicates that write operation is being executed at the external memory. P3.7, which is a read bar, that is on pin number 17. This pin is used to show the read operation. Basically, the hardware generate an active low signal at the pin for the case of read operation from the external memory. The next pins are XTAL2 and XTAL1. These are pin numbers 18 and 19 respectively. These two pins are allotted for internal clock signaling. The external oscillator forms a connection to these two pins so as to have an internal clock signals to the system. The next pin is RST on the pin number 9. Reset pin gives active high whenever the microcontroller is required to be set to its initial state. For proper reset operation of the microcontroller at a time of running oscillator, this pin must be kept high for 2 consecutive mission seconds. The next pin is PSEN bar on the pin number 16. PSEN is abbreviation for Program Store Enable. An active low signal at this pin shows that read operation is being executed from the external memory, either it is from ROM or ROM. ALE, it is address latch enable pin. An active high represents the presence of address in the multiplexed address and data bus. The enabling of this pin provides information to memory and IO devices, that is input output devices, about the fetching of the data from the desired address. Next one is EA bar / VPP. Whenever there is a need to access the program from external memory, then the signal at this pin must be active low. While in the case the code is not accessed by the external memory, then it has an active high signal. I am going to discuss the 8051 microcontroller architecture. The slides are prepared by referring the textbook The 8051 Microcontroller by Kenneth J. Ayala, publication Singh's Learning. The 8051 microcontroller is designed by Intel in 1981. It is an 8-bit microcontroller. It is built with 40-pin dual-in package, 4 KB of ROM storage and 128 bytes of RAM storage and 2 16-bit timers. It consists of 4 parallel 8-bit ports which are programmable as well as addressable as per the requirement. The on-chip crystal oscillator is integrated in the microcontroller, having a crystal frequency of 12 MHz, rounding actual frequency is 11.0592 MHz. The 8051 microcontroller architecture contains an 8-bit CPU, that is ALU, with 2 registers, accumulator and register B. Internal ROM, which has a flash memory of 8K bytes that supports in-system programming. The internal RAM of the 256 bytes, the first 128 bytes of RAM, that is 002 7F, is again divided into 4 banks with the registers R0 to R7 each bank, 16-bit addressable registers and 80 general purpose register. The higher 128 bytes of RAM, that is 82 FFH, consist of SFRs, that is special function register. Using SFRs, we can control different peripherals like timers, serial port and all IO ports, etc. The 32 IO ports or IO pins are arranged as 4 ports: port 0, port 1, port 2 and port 3. It consists of an 8-bit stack pointer. It consists of an 8-bit processor status word PSW. It consists of a 16-bit program counter. It consists of a 16-bit data pointer DPTR. It consists of 16-bit timers or counters, that is timer 0, timer 1. We can use in multiple operations. Various control registers like serial control SCON, power control PCON, timer control TCON, timer mode T mode, and interrupt priority and interrupt enable registers. Serial data transmitter and receiver for full duplex operation. Interrupts. 2 external and 3 internal interrupts are there in 8051 microcontroller, oscillator and clock circuit. The figure 1 shows the architecture of 8051 microcontroller. Here we have the ALU, arithmetic and logic unit, which it is going to take 2 operands. One will be passed through accumulator A register. The second one is through B register depending upon the program. Next, these will enable through the bus. Next, depending upon the result of ALU, the program status word will be modified because it is consist of few flags. It is consist of a program counter and a DPTR, the data pointer. We have a special function registers RAM of size 4K and 4K of ROM. 4 ports we are having port 0, port 1, port 2, port 3. And system timing, system interrupt timers and data bus buffer memory controls. These are used with the various control signals. This is internal RAM structure which is consist of register bank 0, 8 registers, bank 1, bank 2, bank 3. On the top of this we have scratch pad which we can use as byte or bit addressable area. On the top of this we have few SFRs. Few SFRs are interrupt enable, interrupt priority, power control, SBUF, SCON, TCON, T mode, TL0, TH0, TL1, TH register. Accumulator. There is register A which is having an address of E0H. It is an 8-bit register used for many operations including addition, subtraction, multiplication, division and Boolean bit manipulation. This is also used for all the data transfers between 8051 and any external memory. It can be also used as a general purpose register. The results obtained from most of the arithmetic and logical instructions are always stored in accumulator. Implicit or specified in the instruction depending upon the instruction. For few instructions, the accumulator will act as implicit operand. For few instructions, we have to specify in the instruction. The next one is B register, which is having an address of F0H. It is an 8-bit register especially used for direct multiplication and division operation with the accumulator. Both A and B registers are called math registers in 8051 family. It can be also used as a general purpose storage location with its direct access through the address F0H. Next one is stack pointer. It is an 8-bit register used to keep track of stack. Stack pointer is initialized to 07H on reset. 2 instructions, that is push and pop, modify the stack pointer content. When push operation is used, the stack pointer is first incremented and then data is pushed onto the stack. When pop operation is used, the data is retrieved first and then SP is decremented. SP can be reinitialized to any address as desired by the user. Stack defined anywhere on the 128 bytes RAM, but the default address on reset is 07H, but it can be programmable for any another address also. Data pointer, the direct address is not there for DPTR, but it is divided into 2 8-bit registers for which we have memory address. It is a 16-bit register used to hold the address of internal or external data memory as well as code memory. This is only register used to access data from 16-bit external memory. It can be used as 2 8-bit registers, namely DPH, data pointer high, and DPL, data pointer low. The data pointer does not have any direct address, but the data pointer high DPH register and data pointer low DPL registers are assigned with address 83H and 82H respectively. Next one is program status word PSW, which is having an address of D0H. It is an 8-bit registers having 5 flags, including 4 conditional flag, 1 a general purpose user flag, each flag corresponding to a bit in status register. It has 2 additional bits RS0 and RS1 for register bank selection, which can be modified by the user. The conditional flags are set or reset by the result of arithmetic and logical operations. The user flag can be set or reset by programmer as they decide. The format for program status word is shown in table 1. Bit 7 corresponding to carry flag, bit 6 corresponding to AC, that is auxiliary carry, bit 5 it is for F0, which is user defined flag, bit 4 and bit 3 it is for RS0 and RS1 selecting a register bank. As 8051 microcontroller is consist of 4 register banks, each register bank is consist of 8 registers from R0 to R7. To signify which register bank we are accessing for registers R0 to R7, that will be decided by the lines RS1 and RS0. Bit 2 is corresponding to OV, which is for overflow flag. Bit 1 is not assigned for any purpose. Bit 0 is assigned for parity. Bit 7 carry flag. Carry flag is used in arithmetic, jump, rotate and boolean instructions. So whenever you perform the arithmetic operations like addition, subtraction, if any carry is generated or if any borrow is taken, when we are performing addition and subtraction respectively, the carry flag will be affected. If carry flag is equivalent to 0, it indicates there is no carry or no borrow is taken. Similarly, when we go for jump instructions, we are going to check the carry flag for few instructions. Rotate instruction, when we are rotating the contents towards left side, then the MSB bit will be moved to carry flag. When you are shifting the contents towards either rotating or shifting towards right side, then LSB will be placed into the carry flag. Next bit is corresponding to bit 6, which is auxiliary flag. Auxiliary carry flag is used for BCD arithmetic operation. So if any carry is generated or borrow is taken in the lower nibble, then auxiliary carry flag will be affected. Bit 5, that is F0, user defined flag 0. For any application, if the programmer needs or decide a user defined flag, then we can use this F0 bit. The next one is bit 4 and 3, which are RS1 and RS0, which is for selecting the register bank. Register bank selection 1, register bank selection 0. If these two bits are 0, 0, bank 0 will be selected. So 0, 1, bank 1, 1, 0, bank 2, 1, 1, bank 3. So if you see the memory, here we have bank 0, then bank 1, on the top of this we have bank 2, then we have bank 3. These are the 4 registers bank we are having. Every register bank is consist of the registers R0 to R7, R0 to R7, R0 to R7, R0 to R7. Suppose if I write instruction move A, R0, which will signify the R0 register contents will be moved to accumulator. Now this R0 register, as it is present in register bank 0, bank 1, bank 2, bank 3, which R0 we are accessing here, that will be decided by RS1 and RS0. These two bits are 0, 0, then this R0 is corresponding to bank 0. If these two bits are 0, 1, R0 is corresponding to bank 1, 1, 0, bank 2, 1, 1, bank. The next one is bit 2, which is overflow flag. Overflow flag is used in arithmetic operations. Bit 1 reserved for future use. Bit 0 parity flag. It will use the number of 1 present in the data. So whenever this bit is equivalent to 1, it indicates the odd parity. The next one is program counter, PC. There is no direct address for it. It is a 16-bit register which holds the address of the next instruction to be executed. It is also called as instruction pointer in few process, and it is not directly accessible to the programmer. PC is automatically incremented after every instruction and may be altered by certain program control instructions. It does not have any internal address. When internal RAM is used, then PC has to address locations from 0000H to 0FFFH. When PC exceeds 0FFFH, then it will be access the external memory if interfaced, else error will be generated. The next one is SFRs, which is special function registers. SFRs are a group of registers used for specific purposes in 8051 microcontroller, mainly to configure, control and operate. Each SFR is an 8-bit register which uses address locations from 80H to FFH just above the scratchpad area in the internal RAM. All SFRs are shown in the table 2 in the next slide. Note these registers, whichever the registers are marked with the star, that is asterisk, they are both byte and bit addressable. Accumulator A with the address F0H, E0H, B register F0H, PC program counter is not having any address, DPTR data pointer is not having any address, DPH data pointer higher byte which is having the address is 83H, DPL data pointer lower byte which is having the address is 82, SP the stack pointer which is going to have the address is 81H, PSW program status word which is having the address is D0, port 0 PO which is having the address is 80, port 1 P1 which is having the address is 890H, port 2 P2 which is having the address is A0H, port 3 that is P3 which is having the address is B0H. For these registers which are given with the star, they indicate it is for bit addressable as well as byte addressable. These registers, let us assume port 0, either we can access with the name P0 or we can access with the address 80H. The next SFRs are TH0 which is timer 0 higher byte having the address is 8CH, TL0 timer 0 lower byte which is having the address is 80H, TH1 timer 1 higher byte which is having the address is 80H, TL1 which is timer 1 lower byte which is having the address is 8BH, TCON timer control registers with the address 88H, TMOD timer mode control registers with the address 89H, SBUF serial data bus buffer which is having the address is 99H, SCON serial port control which is having the address is 98H, PCON power mode control which is having the address is 87H, IE interrupt enable with the address A8H, IP with the interrupt priority having the address is B8H. Input output port, that is port 0 to port 3, latches and drivers. External bus of 8051 is grouped into 4 ports. The ports are namely port 0, port 1, port 2 and port 3. These ports supports all the 3 types of buses, namely address bus, data bus and control bus. Port 0 to port 3 is used to interface 8051 microcontroller to an external devices like memory, input-output peripherals, interrupt-driven systems, clock, several devices, etc. All the ports are bidirectional. Each port consists of latch and output driver and an input buffer. The address of the ports are given in the table 2. Port 0 having the address is 80H, port 1 90H, port 2 A0H, port 3 B0H. Serial data bus buffer internally had 2 independent register, transmit buffer which is for converting parallel to serial out, that is PISO, and receive buffer which will convert serial to parallel out which is SIPO configuration. Identified by SBUF and allotted an address in the SFR. Timer registers. Timers are, there are two timers are we can use as counters, that is T0 and T1 in 8051 microcontroller, each with 16-bit register. Timers are used to count the internal clock pulses or keep track of internal events. Counters are used to count external clock pulses or events. The timer or counter are divided into two 8-bit registers called TH0 and TH1 for timer 0, TH1 and TL1 for timer 1. These timers or counters can be independently programmed in different modes. Address bus. 8051 supports a 16-bit address bus to connect for external devices like memory and I/O devices. This 16-bit address bus can be used to access the external 64K data memory and external data 64K program memory. The lower order bus is multiplexed with the data bus on denoted with AD0 to AD7. Port 2 provides an next 8-bit higher byte address, that is A8 to A15. The port 0 and port 2 pins together have 16-bit address bus, that is A0 to A15. Data bus. 8051 support 8-bit bidirectional data bus. Port 0 provides the data bus. It is denoted as AD0 to D7. If the data bus is not used for external interface like memory and or I/O devices, port 0 can be used as I/O port. Thank you all. So in this session, we have discussed the architecture of 8051 microcontroller, what are the various blocks which is consisting inside of 8051 microcontroller, and what are the significance of each block we have discussed in detail. So this 8051 microcontroller is having few peripherals on the chips like ports, 4 ports, port 0, port 1, port 2, port 3, 2 timers which we can use as timers or counters of 16-bit size maximum, and interrupt control. Apart from that, it is consist of ROM and RAM memory on the chip. Thank you once again.
Like, share and subscribe. Hit the bell icon for more updates.